Hello everyone, my name is Aryan Jadhav. I am from CSC A section. Today's my Tech Talk topic is about rule of graph in network topology.
In order to discuss the more involved methods of circuit analysis, we must define a few basic terms necessary for a clear, concise description of important circuit features. Node. A node is a point in a circuit where two or more circuit elements join. Example A, B, so on, etc. Essential node. A node that joins three or more elements. Example B, C, etc. Branch. A branch is a path that connects two nodes. Example V1, V2, so on. Essential branch. Those paths are that connect essential nodes without passing through an essential node. Example C minus A minus B, C to D and D to E, etc. Loop. A loop is a complete path, that is, it starts at a selected node, traces a set of connected basic circuit elements, and returns to a original starting node without passing through an intermediate node more than once. Example A, B, E, T, C, A, etc. Mesh. A mesh is a special type of loop, that is, it does not contain any other loops within it. Example A, B, C, D, C, A, etc. Oriented graph. A graph whose branches are oriented is called directed or oriented graph. Rank of a graph. The rank of a graph is n minus 1, where n is the number of nodes and vertices of a graph. Planar and non-planar graph. A graph is planar if it can be drawn in a place such that no two branches intersect at a point, which is not a node. Subgraph. A subgraph is a subset of the branches and nodes of a graph. The subgraph is said to be proper if it consists of strictly less than all the branches and node of the graph. Path. A path is a particular subgraph where only two branches are incident to every node except the initial node. At the internal nodes, only one branch is incident. Concept of tree. For a given connected graph of a connected subgraph is known as a tree of the graph if the subgraph has all the nodes of the graph without containing any loop. Twins. The branches of the trees are called twins or tree branches. The number of branches or twins in any selected tree is always one less than the number of nodes, that is, twins is equal to n minus 1, where n is the number of nodes of the graph. For this case, twins is equal to 4 minus 1 is equal to 3 twins. These are shown by the solid lines in figure B. Links and cotree. If a graph for a network is known as a particular tree is specified, the remaining branches are referred to as the links. The collection of links is called cotree. So, cotree is the complement of the tree. These are shown by the dotted line in the graph B. The branches of the cotree may or may not be connected, whereas the branches of the tree are always connected. Properties of a tree. In a tree, there exists one and only one path between any paths of nodes. Every connected graph has at least one tree. A tree contains all the nodes of a graph, where this is no closed path in the tree, and hence the tree is circuitless. The rank of the tree is n minus 1. Incidence matrix. The incidence matrix symbolically describes a network. It also facilitates the testing and indication of the independent variables. Incidence matrix is a matrix which represents a graph uniquely. For a given graph with the nodes and B branches, the complete incidence matrix A small a is a rectangular matrix of order n cross B. Whose elements can have the following values. Number of columns is in A is equal to number of branches in B. Number of rows in A is equal to number of nodes is equal to. Aij is equal to 1 if branch ij is associated with node I and oriented away from node I. Aij is equal to -1 if branches j is associated with node I and oriented towards node I. Aij is equal to 0 if branch j is not associated with node I. This matrix tells us which branches are incident to which nodes and what are the oriented relative to the nodes. Properties of complete incidence matrix. The sum of the entries in any column is 0. The determinant of the incidence matrix of a closed loop is 0. The rank of the incident matrix is connected graph is n-1. Loop matrix or current matrix. The incident matrix gives information regarding the number of nodes, number of branches, and their connection orientation of branches to the corresponding nodes. It does not give any idea about the interconnection of branches which constitutes loop. It is, however, possible to obtain this piece of information in the matrix form. For this, we first assign each loop to the graph with orientation helps curved arrow flowing in the clockwise direction. As such, orientation is arbitrary. For a graph having nodes and B branches, the complete loop matrix of circuit matrix BA is the rectangular matrix of order B columns, and all, as many rows are there are loops in the graph has its elements have the following values. Bij is equal to 1 if branch j is in loop 1. Bij is equal to -1 if branch j is in loop 1. Bij is equal to 0 if branch j is not in loop I. Thiset matrix and loop currents. A thiset is a set of branches connected in a loop such that each loop contains one link or chord, and remember are trees branches. Consider the graph and the tree as shown. This selected tree will result in three fundamental loops as we connect each link in turn of the tree. Cut-set matrix. Cut-set matrix. A cut-set is a minimum set of elements that, when cut or removed, separates the graph into two groups or nodes. A cut-set is a minimum set of branches of the connected graph such that the removal of these branches from the graph reduces the rank of the given by 1. In other words, for the given connected graph, a set of branches is defined as the cut set if and only if the removal of all branches in C result in an unconnected graph. The removal of all but one of the branches of C leaves the graph still connected. Fundamental cut set. A fundamental cut set is a cut set that cuts the contain one and only one tree branch. Therefore, for a given tree, the number of fundamental cut set will be equal to the number of the twins. Properties of a cut set. A cut set divides the set of nodes into two subsets. Each fundamental cut set contains one tree branch, the remaining elements being linked. Each branch of the cut set has one of its terminal incident at a node in one subset and in other terminal of a node in the other subset. A cut set is oriented by selecting an orientation from one of two parts of the other, generally the direction of cut set. Cut set matrix QC. Chosen same of the direction in the tree branch for the same given graph. A cut set matrix QC is defined as the rectangular matrix whose rows correspond to the cut sets and columns correspond to the branches of the graph. Its elements have the following values. Qij is equal to 1 if branch j is the cut set I and orientations considered. Qij is equal to -1 if branch j is in the cut set I and orientation do not consider. Cut set matrix and KVL. But cut set schedule the branch voltages and expressed in terms of tree branch voltages. A cut set consists of one or only one branch of the tree together with any links which such be cut to divide the network into two parts. A set of fundamental cut sets includes those cut sets which are obtained and applying cut set division for each other. Given is the circuit diagram is a graph and the tree, and incidence matrix, die-set matrix, cut-set matrix, and its KVL and also KCL. Formulation of network equilibrium equations. The network equilibrium equations are the set of equations that completely and uniquely determine the state of the network at any instant of time. These equations are written in terms of sustainable chosen current variables or voltage variables. These equations will be unique in the number of independent variables be equal to the number of independent equations. Generalized equations in matrix forms for circuits having sources. Node equations. The node equation becomes YVN is equal to A of YBVS minus IS, where Y is equal to AYS is called the nodal admittance matrix of the order of n-1 into n-1. The above equation represents the set of n-1 numbers of equations known as node equations. Mesh equations and mesh equations become ZLL is equal to BA into ZBIS minus VS, where Z is the or loop impedance matrix of the order B minus n plus 1 into B minus n plus 1. The above equation represents a set of B minus n plus 1 number of equations known as mesh or loop equations. Cut set equations. The cut set equations become VCVI is equal to QC into YBVS minus IS, where YC is the cut set admittance matrix of the order of n-1 into n-1, and the set of n-1 equations represented by the above equations is known as cut set equations. Thank you.